let's go ahead and get started. I think a few. Okay, do you want to ask the questions first? Go ahead.
So it was from more operators assignment, and the question was the following: parenthesis x modulo 2 parenthesis closes is 1.
Okay.
Then question mark and parenthesis opens x plus 1 parenthesis closes.
Okay, so is that more operators or
yeah, more operators.
Okay, more operators. And I'll show you. Continue the last preview. Okay, so let me know which question we are dealing with here. Let me go through the questions one by one.
The one with the if statement.
Okay, but this one I have not closed yet, so I can only kind of talk about the general ideas, but not really the answer.
Yeah, this one.
This one?
Here, yeah.
Okay, what is your question?
How do we solve it, really?
Well, you do it step by step.
Yeah, and I still get the wrong answer.
You still get the wrong answer?
Yeah.
Well, I cannot
twice.
really show you exactly how to get to the answer, but I can show you at least the steps that you can take to answer the question. So the parentheses in this case, clearly shows, the order of what you need to do. In other words, if I do not give you the parentheses and only rely on the priorities of the operators, it'll be a little bit more difficult because then you have to look up the actual priority of operators and then decide which one you have to apply first. But since I used parentheses to group all of these operations, so what you need to do is to follow the parentheses. Okay, that's the first thing. Second thing is then you have to understand what is the ternary operator, which is the question mark and the colon. Okay, so those two symbols represent a ternary operator. So let me point out what I'm talking about here. This symbol and this symbol, they represent the ternary operator. And a ternary operator is an if-then-else statement, basically, but it's done as an expression. So it basically says the first part here is a condition. If the condition is true, then the second component is evaluated and becomes the value of the expression itself. If the first component as a condition is false, then the third component is evaluated and its value becomes the value of the expression.
Thank you.
All right.
Got it.
Okay. Okay. So I think that answered the questions. And I think you guys have got a question? Any question I can answer?
Sorry, no. I'm excited about that.
Okay. All right. So what I'll do is I'm going to put a due date on this one now, which I think is okay, is fair because we have been talking about this for a while already, and I think this time more people are kind of on the job and actually get it done. Or at least try to get it done. So I'll put a due date on this one. Like after the class, I'll give you guys like maybe until Wednesday, Thursday. I'll say until Thursday to get it done. Okay. And then we'll have to move on because this is an operator topic, and we are now on the next one.
One more question.
Yep.
There was this int 16t, the conversion question.
Yes.
And so, if like x is 32, express the answer in binary base 2. I just converted it to a binary and I get like -1001. It's still wrong. Is there something I'm doing wrong again?
Okay. Well, okay. Let me get to that other one first, and then we'll move on. So it's a part of more operators. Yeah, because typecast is a part of more operators. Okay. So let's get to that one. Nope. This one. This one.
Yeah.
Well, you have to find out what this operator is. The fact that you tell me it's a negative something, that means you're not understanding what the tilde symbol means.
I looked it up on the C++ page. It says it's not in 16 or whatever.
It is bitwise not.
Yeah.
Yes. And we talked about it also in class. I got notes on this one too. So what you need to do is to turn it only makes sense to apply that to a binary number. Okay? Or it is visible only when the whatever you're working on is a binary number. So whatever the tilde symbol or whatever the bitwise not is operating on, which is this part here, you have to see it as a binary number first. That's the first thing you need to do, is to look at this part here as a binary number, and then you apply the bitwise not to each digit of the binary number.
Oh, okay.
Okay? All right. So any other questions? No other questions? Okay. All right, so we are going to finish up control structures today, and then we'll start to move on to C in, C out, and how to do all the input output in C and C++. Okay? And the only topic left for control structure that we have left so far is how do you nest one control structure as a part of another control structure. So that's our last topic. Actually, I got it already loaded a little bit earlier. So the question is, how do we get it done? Well, I mean, obviously it is doable, because otherwise, C and C++ would not be a very useful programming language if we cannot nest control structures. So the question is, how do we do it, and is there a good way to do it and a bad way to do it? Okay, that's the question. So what we want to do is to say, well, let's do some examples first. Okay, if you look at this code here, it definitely is a nested structure, because it starts off with a for loop as the outermost construct. Okay, but a for statement expects only one single statement as quote unquote its body. In other words, the code to be done repetitively is only one statement, which in this case is okay. Okay, let's see if we can see this from the perspective of the compiler. Okay, because that really is the best way to explain things. So the compiler will first see this keyword here. It's FOR, for, which tells the compiler what is following is going to be a for loop. Okay? As far as the compiler is concerned, now it is expecting several things. It's expecting an open parenthesis, a precondition or an initialization expression, a semicolon, a condition to evaluate on a per iteration basis, and then a semicolon, a post-operation expression, close parenthesis, and a single statement after the close parenthesis. Okay? So as soon as the compiler sees the word for, it is now expecting all of those other components to appear. Are we doing okay so far with what the compiler sees? Okay. So the first part is pretty simple. Okay. So it sees the open parenthesis here, and as an expression, you can actually declare an operator, also. Obviously, this one is not very good because it does not initialize I, but it is still an expression that is okay. It is now seeing the expression that is evaluated on a per iteration basis. It is now seeing the post operation, a close parenthesis. So right at this point, right after it processes the close parenthesis, it is now expecting a single statement. And what does it see? It sees a keyword if. So what do you think the compiler is thinking now? It's saying, oh, cool, okay, we have a conditional statement as the only thing to do again and again in a for loop. That's what it's thinking, okay? So it sees this if statement, and it immediately says, okay, the nested statement is a conditional statement inside a for statement, and now I'm expecting open parenthesis, a statement to evaluate for the condition. Okay, do you guys have any questions back there? Anything that you can ask in class? No? Okay. Go ahead.
Are you forgetting the quotation or the brackets for the first two?
They're not necessary.
They're not necessary.
They're not necessary because without the open and close curly braces, what happens is the compiler is just saying, okay, I'm expecting one statement. But that statement can be a conditional statement, can be another for statement, can be a while statement, can be a do while statement. It's just, quote unquote, one statement.
So the for is expecting if, and then if is expecting the and.
No, the for is expecting a single statement, and it sees if, which means the one statement that we are doing over and over again is a conditional statement in this particular case. Okay. So now that we are seeing the if keyword, the compiler says, okay, I'm expecting open parenthesis, a statement, an expression to evaluate for true, false, a close parenthesis, and another single statement. And then it sees, oh, okay, I see an and here. Now, and is not for, it is not if, it is not switch, it is not do, it is not while. So at this point, the compiler says, okay, I think I know what it is. It's just an expression statement. Okay, because it's none of the other control statements, so it has to be an expression statement. Okay, an expression statement is an expression followed by a semicolon. That's all it is. So now it sees the and it says, okay, it's an expression statement. What is it? Oh, I can see the operator here is the assignment operator, and the assignment operator needs the other side. This is the other side, and as expected, there's a semicolon here, which turns it from an expression into a statement. So right here, as soon as the compiler processes this semicolon, it will close a few things. Because one, it will understand n gets n plus 1 is an assignment statement. Okay, that's done. It will also say, oh, now I have found the statement of the conditional statement. So that will also close the if here. But as soon as the conditional statement is finding its end, it will also tell the for statement and say, okay, I have found your end as well, because the for statement has now completed its own statement. It's the nested statement of the entire conditional statement. It's the only statement that you want to do with the for statement. So seeing that one single semicolon at the end is going to close the entire thing. The entire nested structure will basically be finished by the time we see the last semicolon symbol. Yep.
Sorry, you said the last semicolon turns it from an assignment into a statement, or an expression into a statement?
It turns an expression into an expression statement, yes. So it effectively turns it into an expression.
It turns the expression into an expression.
Into an expression statement. So are there, yeah, go ahead.
Will that actually work? Or because I don't see where the K is initialized for
Well, as far as the code is concerned, how it is structured, it works okay. As far as whether it will do what we think it should, there's no such thing as what we think it should do, because I haven't really said what the code is supposed to do. So I'm just talking from the syntactic level. What are we talking about here? Which statement is nested within each one, which other one, and so on. Question? Okay, go ahead.
So you're saying that once he gets to the if the statement is not true, it says false, it's still executed anyway? So if you say
No, if I equals to k, it will do the n gets n plus 1. If I does not equal to k, it will not do n gets n plus 1, but it will still go back because it is a part of a loop. The conditional statement is a part of a loop. So even if the conditional statement has nothing to do, it still has to continue with whatever the loop needs to do, which is to increment I and then do another comparison.
oh, okay, so you go back up.
Yeah, so it will go back. And it will keep doing this until I is less than 3 is no longer true. Yeah. Okay. Any other questions about this? No other questions about this? Okay. So now, let's take a look at this code here. If we understand the previous program, let's look at the second program here, which is very similar to the first one. Except, I just remember one thing, okay? Whenever I add 1 to n, I also have to decrement 1 from m, okay? I just remember that, okay? No big deal. So I'm going to add that part as a part of this program, as a part of this code here, okay? What's going to happen when I try to compile this code? The compiler says, no problem, okay? When you look at this code, it looks like it should do what it's supposed to do, especially if you have been programming in Python for a while, except it does not do what you think that it is supposed to do. Yep.
It's only doing n plus 1, and then it's repeating that how many every time, and then after it's done, then it's going to...
After what is done?
After the condition is true, the I is 3, it's less
After I is less than 3 is no longer true, we get out of the loop, and then it will do the m gets m minus 1. Okay?
So if it's like a 4, I equals to a 4, it will still continue in the loop.
No, because I is plus.
Okay, let's take a look at this code from the perspective of the compiler. Okay, kind of like last time. Okay, the compiler says, okay, I see the word for. Now I'm expecting the following components. Open paren, one expression as the initialization, one expression as the condition to stay in the loop, one expression to be the post operation, close parenthesis, and one single statement after the close parenthesis. Those are the components of the for loop. Okay? So now that I'm the compiler, I keep processing, right? I see the open parenthesis, no problem. I see the initialization, no problem. I see the condition to stay in the loop, no problem. Post operation, close parenthesis, and now at this point I'm expecting a single statement after the after the whole thing. And what do I see? I see an if word here. Okay? If says, okay, this is the beginning of a conditional statement. A conditional statement is a statement, so that's perfectly okay as a component of a for loop. Is that part okay? But as a conditional statement, what is the compiler expecting? The compiler is expecting the following: open parenthesis, an expression as the condition of the conditional statement, close parenthesis, and then a single statement after that. Okay? But in this case, what is the compiler seeing? Well, it's seeing open parenthesis, an expression that is the condition of the conditional statement, a close parenthesis, and a single statement. And the compiler is happy as a clam and say, okay, I have found everything now. I have found everything that the conditional statement is expecting. I have also found everything that the for loop is expecting. But what about m gets m minus 1? It has nothing, absolutely nothing to do with the conditional statement, nor the loop, nor the for loop. Yep.
So just being ignored or left?
It's not ignored. It is a statement that is basically right after the entire for loop. In other words, at the top level, the compiler sees this as one single statement, and it sees this statement as the one after that. So m gets m minus 1 does not execute until we get out of the for loop. It is not a part of the conditional statement, nor is it a part of the for loop. It's not a part of the if, nor the for.
So your last sentence in the paragraph above,
Right.
The indentation seems to clearly indicate which statement contains which other one.
Right.
So
It's misleading.
yeah, so I mean, by looking at that syntactically, that M statement is part of the if statement.
But it's not.
It's not.
It's not, and not only that, it is syntactically still correct. It just doesn't do what you want it to do, or what the indentation thing, it indicates that it should do.
How do you fix it?
Well, the way I fix it is to make it very okay. Okay, let me use a text editor here. The way I fix it is something that I have talked about a few times in this class, is to use a lot of extra open and close curly braces, even when they don't seem to be needed. Okay, so let me go ahead and try to write this code again, but this time using the convention that I've been talking about. So let's start with this one here. Okay, so the way I write my code is like this. Whenever I want to use a for loop, this is what I do. Okay, the entire template with open curly brace, close curly brace, the semicolons and whatnot, and then I go back and say, oh, okay, what do I need to do here? Int I is less than 3, plus I, and then inside here, what am I supposed to do? I have a conditional statement, and whenever I do conditional statement, this is what I do. I put in the entire framework of everything that you can possibly want from a conditional statement. All the curly braces, the else branch and all that stuff. And then I go back to the actual logic that I want to implement, which is very simple, right? I equals to k, and n gets n plus 1 is the only thing I want to do in this version of the code, okay? And you will say, wow, that is a lot longer than the other one. Okay, this does exactly the same thing as this one here. Doesn't do any more, doesn't do any less. It doesn't take up any extra time to execute, because when you have open and closed curly braces, it doesn't do anything with execution time. It just takes up more lines in your source code. If you have an else branch that doesn't do anything, it does not use up any more time. It's just sitting there doing nothing. Okay, so it doesn't seem like why would I even bother with all these extra curly braces and whatnot. So when it is time for me to quote unquote fix the program and say, oh, you know what, I forgot, I also want to do a m gets m minus 1 as the then branch of the conditional statement, I can now go back here and just say, oh, m gets m minus 1, semicolon, and the program is fixed without the possibility of confusing myself and go like, well, is that really a part of the conditional statement? Oh, yeah, it definitely is. So that's the quote-unquote fix. It's not even to start programming the way that I was talking about earlier, is to use the extra curly braces from the get-go.
But doesn't that still not evaluate 1 until I less than 3 is not true?
Now, if you look at this particular code, this is what the compiler sees. The compiler sees the for keyword, which means, okay, this is the beginning of a for loop, and it's now expecting the various components. The first part is trivial, okay, because it's the same as the case before. But the question is, what is this? As far as the compiler is concerned, this is a single statement. It's called the block statement or the compound statement. Okay, so now the compiler says, okay, this statement starts here, and I have to see this end curly brace to mean the end of this quote-unquote one single statement. So the nesting is now explicit. I'm not relying on the compiler saying, oh, I'm expecting one single statement, and here's that one single statement. I'm using a block statement here, which means I can have as many statements as I want within the block, and it will still count as one single statement as far as the for loop is concerned. So my solution is not even to get into this problem to begin with by placing those, extra curly braces even when they are not needed. Okay, not needed is one thing, but they don't really introduce any problems either. They don't take up any execution time, and it doesn't change the logic of the code. They're just sitting there doing like, oh, okay, this doesn't seem necessary, but it's just sitting there.
Okay.
Yep.
So in the example code, if you put open curly braces before the n equals n plus 1,
that would fix it also.
Okay.
Right. That would be the minimal fix. Right.
So then it wouldn't be looking for the semicolon, it'd be looking for a closed curly brace.
Okay, so you're talking about the program that looks like this, right? So you're doing the minimal fix like so,
Yes.
right? So in this case, when the compiler sees the if, it will still say that, okay, this is the one statement inside the for. Okay? But the if itself is also expecting one single statement. So instead of finding n gets m plus 1, which is an expression statement, it is now seeing the beginning of a block statement. And it says, okay, I'm seeing a block statement. This is my content. But as far as a block statement is concerned, it does not end until you see the end curly brace. So as far as the if statement is concerned, it contains everything from the then branch, is everything from the open curly brace to the closed curly brace.
My question is it still looking for the last semicolon though?
Yes, it is still looking for the semicolon, because as far as a block statement is concerned, it can have any number of statements. So when you process n here, as far as the compiler is concerned, it will try to match n with the keyword of all the known control structures that it knows. Okay, like while, do while, for, if, switch, which we haven't talked about. So it will try to match it with all the known keywords, and it doesn't match any known keywords. So that's an indicator to the C compiler and say that this is not really a control structure. This is the beginning of an expression statement. Now, note that I use the word expression statement, not expression. So as an expression statement, it is expecting an expression and then a semicolon. So it will process everything up to this point here and say that, okay, I have just processed an assignment expression. But since it is supposed to be a statement, it is now saying, okay, I can either see a comma and then another expression for a comma separated expression, or I can see a semicolon to end this particular expression and turn it into a statement. So you will still need that semicolon here. The only thing you can do, or option here, is instead of using a semicolon here, you can turn this into a comma, and this code will still do the same thing. Because if you turn it into a comma, then we have one single expression statement inside the block statement, because a comma can be used to separate multiple expressions into one huge expression. So now we have one single expression, but that single expression still has to end with a semicolon, which is now on the next line. Yep.
So you can have it like that on the next line without.
This is syntactically correct. But in terms of semantic, it is a little bit different.
And if I've had this question for a while, all the fors, all the if statements, they don't need to have like an and for or and if. Like,
No, they do not. The syntax of C does not use and for, and if, and so on, which makes it less, more confusing, because now it is difficult to say, okay, I see an and curly brace here, but what is it ending?
Yeah, where's the end?
Right? Yep. That's why C is a little bit more cryptic than the pseudocode that we used, in the previous semester. Any other questions about this code? No other questions about this code? Right? Okay, so we look at this code here. Once again, it is not, doing what the indentation suggests it is doing, and yet it is syntactically correct. Okay, so if you are the compiler, how are you going to process this? You first see the word for, and then you are now expecting the three expressions in parentheses and one single statement. We have the three expressions in the parentheses and one single statement. So what that means is the conditional statement, which is this part here, is not a part of the for loop. This is a statement that is after the for loop. So we'll first perform the for loop, and then we'll process the conditional statement. That's how things are ordered, and yet it is syntactically correct, because as far as C and C++ is concerned, new line, which is opening another line, means nothing. Indentation also means nothing. As far as C and C++ is concerned, they're both considered a single space as far as the compiler is concerned. What does that mean? They're considered exactly as a space. That means when I look at this code here, as far as the compiler is concerned, I could have written this exactly the same like this. Put everything on one single line. This one here. Okay, so this code here in the browser is exactly the same as this on a single line. C and C++ is going to process exactly the same way. So it is your responsibility to use the indentations correctly, because if you use indentations incorrectly, your code will indicate a nesting structure that does not match what the compiler is actually seeing. Are there any questions about that part? Okay, I have a question. Okay, throughout the course of writing a program and fixing it and whatnot, I'm going to screw up the indentations. Okay, the open curly brace, close curly brace. At some point, the indentation is going to be so messed up that I will have to spend a lot of time to get it fixed up again. So is there a shortcut to get this done? It seems like a mechanical thing, and maybe the compiler can help me, or maybe the computer can help me do this. And the answer is yes. Okay, there are programs that can help you reformat the source code of your program so that your indentation is once again correct. Those programs or tools are called beautifiers. No, I'm not kidding. That's the actual name of that type of tool. It's called code beautifier or formatting tool. Yep.
So if a new line and a new indentation effectively mean one single space.
Indentation and line feed, they're both considered as a single space.
Right, so with that being the case, the indentation is strictly for someone else looking over my code.
Yes, or yourself, right? Yeah, exactly. So the next thing I want to do is really just quickly go to like C++ beautifier, and they have online stuff like that too, so it makes it kind of easier. Beautifier.de. Okay, and with this one, it allows you to add new lines after open curly brace and before close curly brace. Add new line before open curly brace. Okay, so let's give it a try, right? Oh, can't do that. It's blocked by an extension. Okay, let's do it with another website, maybe.
American College doesn't like it.
It could be a Java thing. I think it's a Java thing. Unholy coding. Okay. I think Debian might have one too, so let me check that. Not by name. And CodeBlocks may have a way to do it also. I'm not 100% sure. Let's check that. Well, since I only use simple tools, how do you think I beautify my own code? I try to structure my code from the get-go, so I don't need to reapply that technique. Because by the time you actually have to do it, it usually implies that you didn't really think through your code carefully to begin with. So sometimes I would just kind of rewrite the code so that it's well structured again. And let's open the tools. It has Valgrind, but I don't see a beautifier. Okay, well, we'll spend some other time to do this, but the key point here is indentation. You have to use it carefully because the compiler does not care about your indentation. All right. Are there any questions about control structures in C and C++? No questions? Was it a boring topic? If you combine everything that we have talked about regarding expressions and everything that now we have talked about with control structures, we can make some fairly complicated code already. Okay? Especially with the use of a ternary operator and a comma operator, because those two really turn expressions into something that is a lot more powerful than what people think of expressions. The next topic is, in my opinion, kind of more of a boring topic. How to do input and output using files. That is boring. Okay, so we'll start off with a very simple question. What is a file? And without reading it, okay, well, you can read you can see a certain part of this, or for those of you who read ahead of me, you already know the answer. What exactly is a file when it comes to computers?
Something that stores something.
Okay, somewhere to store something. Okay. What if I tell you a file is nothing really more than something that you can send a byte to and something that you get a byte from? That's a file. Okay? It's not necessarily something they can store on the computer itself. Okay. So what do you mean by that? Well, let's go ahead and read this portion here, because it will give you everything that you need to know about a file from the perspective of computer programming. Okay. Okay, a file is an object in the file system that can store a picture, a document, and so on. And that's what people understand what a file is. Most people also understand a file has a name, it has a folder that contains it, a file can be copied, deleted, or moved. So what else do we need to know about files? Well, what if I tell you something like this? What if I tell you there are certain files that has no folder that contains it, it has no name, it doesn't store something, okay? The only thing you can do with that file is you can send it something, or you can ask it for something. Okay, that's basically what a file really is from the programming perspective. Okay? So instead of talking about files in programming, we usually refer to those using the name of a stream. So a stream, as the name implies, is basically just a stream of bytes. Okay, it's just a continuous sequence of bytes that you can either write to, so you can basically say, okay, here's another byte, or you can get it from, and I'm getting another byte, I'm getting another byte. Look at it as a conveyor belt. Okay, that's the best way to visualize what a stream is. It's a conveyor belt. Okay, so if you look at it as a conveyor belt, you can do two things to a conveyor belt of stuff. Okay, you can either put something on the conveyor belt, or you can retrieve something from a conveyor belt. And those are the most basic operations with files as far as programming is concerned. Is we can get something from the file, we can write something to the file. Is that something really stored? I don't know. Is it really stored to a file that has a name inside a folder? I don't know either. I just know that I can put something on that conveyor belt. Where does it go to? I don't even know that. Maybe it goes to a black hole. And there is such a thing called a black hole in programming. It's called /dev/null. You might find T-shirts with that, reference to. Okay. All right. So let's go ahead and just kind of do something with these concepts already. Without writing our program, let's do something about this. Okay. So what we're going to do is to say, okay, let's look at all the files that are already in the system. So if you do a ls in Linux, it will display all the files in the current working directory folder. Or if you want a fancy version of this, you can do ls -- color, which uses color coding to tell you that, oh, dark blue is a folder, light green is an executable, everything else is just a regular file like that. Okay. So in this case, nothing is exciting. I mean, the file is just what we know what a file is. Okay. So we'll now look at a special folder called /dev, which exists in every single Unix type platform. Windows NT actually has a similar structure. It's just that most people do not know about it because they don't really want people to understand that it's not DOS anymore. And inside /dev is what we call a null device. A null device is a black hole. It is a file, but whatever you write to that file disappears. Okay, and there's also a file called 0. Okay, what do you think that file? What do you think is the equivalence of that file? It's an endless stream of zeros as bytes. Okay. Yep.
So is it the trash can on the desktop?
It's not a trash can. It does not delete a file. It's just that whatever you send to it, disappears.
Okay.
But what you send to it are individual bytes, not files.
Is the trash can?
It's not a trash. It's just a place where okay, let's say your program has spews out lots and lots of output. Okay, and one day you just kind of sick and tired, and your program is working. You don't want it to output everything on the screen. You redirect all that stuff to /dev/null, so it doesn't do anything. So your screen is now clean. It doesn't do any output to the actual screen. We'll talk about redirection later, because what you're asking is related to the concept of redirecting. Okay. So actually, this is what we're going to do next. Okay. So let's go ahead and try to do something to see what is coming in from /dev/0. There are several commands you can use. Okay. By the way, there's also another file. No, one is not one of those. There's also random file. Okay, the random file is interesting. It is related to security because the random file, or urandom, they're both supposed to give you a stream of random bytes. Now, a byte can only have a value from 0 to 255. So in theory, when you read from this file, you'll just be reading some random bytes, and each byte is from 0 to 255. Okay. Now, but how do we see this stuff? Okay, how do we read from a file that has no end to it, right? I mean, all of these files have no end to it. Well, there's one command that is really particularly helpful in this case. It's called hex dump. Okay, hex dump or hexadecimal dump. Okay, what it does is it prints out characters in ASCII. In other words, it's not printing the letter A as A. It is giving you the ASCII code of the letter A. Does everybody understand what is ASCII code or not? Sort of? Okay. Well, since not everybody kind of responded with confidence, I'm going to talk a little bit about it. Okay. ASCII code is a protocol. Okay. ASCII stands for American Standard Code for Information Interchange. Okay, which is kind of like an odd, long name to describe. It's just a standard. Okay. So what kind of standard are we talking about? Why do we need a standard? Okay. Well, the standard is needed because the way you represent text in a text file is one way. Okay. You know, how do we represent alphabet and punctuations and all that stuff in a text editor? Well, as characters, as bytes, right? Because those are the only things we can store. So you might decide this is my way of representing the lowercase letters, the uppercase letters, the punctuations, the digits, and whatnot. What if your standard does not agree with the printer's standard? What happens when you try to print your file? Then you'll get some gibberish, right? Because you know what you say, oh, I want this binary pattern to be lowercase a, and then the printer says, this binary pattern means open parenthesis. So what you want to print now becomes some gibberish coming out of the printer. So that's why all devices need to come to one single common understanding and say, yes, we all understand this particular bit pattern means this particular letter, or this punctuation, or this digit. Is that okay so far? With the rationale behind ASCII, the ASCII standard. So how do we know what is the ASCII standard? Which code represents what? Well, in Linux, it's easy because you can use the command called man, which stands for manual, and ASCII is one of the topics that you can look up, and it'll give you what we call the ASCII table. So when you read the ASCII table, it looks a little bit daunting. Okay, let me just pick one particular row here. Okay, if you just look at this row here, it looks kind of daunting. It's like, what are all these numbers? I mean, what do they mean? Well, the last column, which is char, tells you that we are talking about the letter B, uppercase letter B. Okay, and now we're asking the question, how is it represented? Well, inside the computer, we talked about this already in this class. Everything is binary. It's either a 0 or 1. B is not a 0. It's not a 1. So how do we represent the letter B as zeros and ones? Well, this is how we do it. Octal, base 8, decimal, base 10, and hexadecimal, base 16. So those are the representations of the bit pattern that we use to represent uppercase B. In other words, when you look at 102 as a base 8 number, 66 as a base 10 number, and 42 as a hexadecimal number, they all represent exactly the same value, which in binary is 0100 0010. Because 4 in hexadecimal is 0100. 2 as a hexadecimal digit is 0010 as a binary number. So together, 0100 0010 as a bit pattern represents uppercase B. Okay, so that's how devices can talk to each other and understand each other because they all use the ASCII code. Are there any questions about the ASCII code here? Now, the ASCII code, because it's a byte-oriented encoding scheme, can only represent up to 256 individual things because you only get 256 combinations of zeros and ones. So naturally, there are certain things that cannot be represented using only 8 bits. So when I press the space key, I'm just going to pick another row here, and say that open parenthesis. Okay, when you look at open parenthesis as something that you want to represent, it is represented by 28 in hexadecimal. 28 in hexadecimal in binary is 00101000. Okay, that's the bit pattern to represent open parenthesis. Are we doing okay so far with ASCII code? How we are actually encoding stuff that we want to print, stuff that we want to transmit, but in zeros and ones. Yep.
For the binary, you're doing like 0010, and then
1000.
How come you're not doing 28 instead?
28.
2 and 8.
Okay, so that's a good question. So let me try to answer that question. Okay, so we want to look at this and the notepad at the same time. Go. Okay, so we are looking at 28 as a hexadecimal number. As a hexadecimal number, each digit can go from 0 to F because it's base 16, so we have 16 choices per digit. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So we basically borrow the alphabet for 10 to 15. Okay? And then when you look at each hexadecimal digit, okay, so we have 1, 0, 1, 2, 3, 4, etc. to A, B, C, D, E, F. Okay. 0 as a 4-bit number is 0, 0, 0. 1 is 0, 0, 0, 1. 2 is 0, 0, 1, 0, and so on. A, which is 10, is 1, 0, 1, 0 in binary. B is 1, 0, 1, 1 in binary, etc. And then F is 1, 1, 1, 1. So every time you see a hexadecimal digit, you convert it into the 4 bits that is representing it. And that makes conversion very easy because there's no division involved, there's no multiplication involved, there's no remainder involved. It's just a table lookup. Now, given that you are just starting with programming, you probably cannot, do this like right away, like what I did. But if you just use this like a few days, you will start to build up the table. You can look at each digit and go like, okay, I can instantaneously translate one hexadecimal digit into 4 individual bits. And that's how I did it. I look at 2, 8. So 2 is 0, 0, 1, 0, and then 8 is 1, 0, 0, 0. So that's how I can do that conversion between hexadecimal, base 16, to base 2 quickly. And that's also why base 16 is widely used in programming, because it's so easy to convert it between base 16 and also base 2 in this case. All right. So are there any questions about how characters are represented? And basically what a file is a conveyor belt where each individual unit is a byte. You're basically just filling it in with 8 bits at a time, 8 bit at a time, 8 bit at a time. Are we doing okay so far with that concept of a file? Okay. So with that file concept out of the way, let's talk about hex dump as a command, which is really kind of handy for many purposes. So if you want to learn how to use a particular command in Linux or Unix in general, you just say man and then followed by the name of that command. Okay, because man is a manual command, and it just looks up the documentation of a particular command. So in this case, it looks up the documentation of hex dump, and it shows you how to use it. You have to spend some time to read these documentation to get used to it. But once you get used to it, there's a certain format to it. Okay, so let's go ahead and do a hex dump -c, which is to display everything as characters from a certain file. So let's see what file we have here that is good for this purpose. So let's see. We'll take a look at the script itself, record screen.pl, which is the script that I run every single day to start a recorder. It's a text file. And, okay, that's scrolling by a little bit too fast. So this is what it looks like. On the right-hand side, you see the actual text as characters. In the middle part, you see the hexadecimal representation of the binary bit pattern. And then the leftmost column is basically, quote unquote, the address of those bytes. So we count from 0. So byte 0 of the entire file is the pound sign here. The pound sign, which is what we see, is represented in binary, in ASCII by 23 as a hexadecimal number, which means in binary, the pound sign is 00100011, because one is a 2, the other one is a 3, so we have that particular bit pattern. So this is a quick and handy way to kind of show you the ASCII code of a particular file. What about this little asterisk here? Well, that's actually not a period, because the ASCII code is 0A, which matches the ASCII code of a line feed character. A line feed character, like backspace and many other characters, are called non-printing characters because they don't really print out as something. They do something else, okay? Like a line feed character is doing both the line feed and the carriage return on a normal printer. So it opens up another line and it rewinds all the way back to the left-hand side on the next line. Okay. So this is a really handy tool because sometimes when you use an editor, you will see only what you can see, but when you use this tool, you get to see the entire content of the file. And this command requires a little bit of explaining too, and it's also related to files. Hex dump, I think can take on a command line to specify which file I want to dump from. Nope. Specify a file. Okay, so I can specify a file just using that. Okay. So I could have just done it like this, and specify the file that I want to dump from, and it would do exactly the same thing, but it's going past a little bit too fast, right? So what we use this vertical bar is what we call a pipe symbol. It takes the output of one command and feed it to the input of the second command. Okay, so now the conveyor belt concept really works, right? Because as a file, quote unquote file, the output of the first command is now the first command, which is hex dump, is now putting all those bytes onto a conveyor belt. But where is that conveyor belt going to? It's not stored anywhere, right? What it is it's being treated as the input of the second command. So the second command has its own conveyor belt for an input file. So in this case, the output of the first command becomes the input of the second command. And those two are considered a file. It doesn't have a name, it's not stored anywhere, and yet it is a file. It's a stream, basically. So let me pull up the row sheet for today. Go. Are there any questions about these commands? It takes a little bit of time to kind of get used to it. No questions or no particular question? Okay. But what I really want to show you is, can we do a hex dump on /dev/0, the infinite source of 0 bytes? Okay. Remember that file is kind of magical. It basically just keeps giving you bytes of zeros. Okay. So what we're going to do is to use the less than symbol here. And then this is becoming, quote unquote, the input to this command, and I'll pipe it to less. What do you think we should see here? Let me just re-explain this particular command a little bit here. Hex dump is the first command. -C means I want to display the input of this file byte by byte as characters whenever it's possible. The less than symbol is what we call a redirection symbol, which basically means, oh, let me tell you what the input file is supposed to be, and this is the input file, which is /dev/ oh, I meant 0, not null, because that's what I'm going to show you. It's an infinite source of bytes of zeros. Okay, it just keeps giving. The bar symbol here means whatever this hex dump is doing becomes whatever the output is from hex dump becomes the input of less, which is what we call a pager. A pager is basically just a utility so that it will display one screen fold at a time, so that you don't see all the stuff scrolling by in just a fraction of a second. Okay, and what do you think we should be seeing?
Zeros.
All zeros, right? It doesn't end because it's an infinite stream of zeros, so it doesn't come to a place where it can stop and show you the content. So it's not a very good example from that
It
perspective.
doesn't follow the less word.
Well, if I don't use the less, it would just kind of
How did you stop it?
Control C. You're following that? I hope you're not doing it on the power server either. That can potentially chew up a lot of space. Okay, so it is a byte, it's a stream of zeros. And it's supposed to be endless too. Okay, there's no end to it. Alright. Okay, let's go back to the notes here. I'm talking about something here that is a little bit more advanced than what the note is really talking about. So we'll continue to talk about, from the notes perspective. Most files are streams. You can consider a file as a stream of characters, of bytes, except for a few cases. Most files can be seen as just a stream. A stream and source bytes can source bytes or it can sync bytes. Now the term sourcing and syncing simply means, is it originating the bytes? Is it putting something onto the conveyor belt? Or is it syncing, which means it's consuming bytes? Is it taking something away from the conveyor belt? So to source is, as a verb, is to put something on the conveyor belt. I'm putting something onto the conveyor belt. Somebody else is going to do something about it, but not me. Okay? To sync something as a verb means I'm taking something away from the conveyor belt. I may be doing something to process it, or maybe I'm not doing anything about it. I'm just tossing it away. But I am taking something away from the conveyor belt. And you can only do it one byte at a time. Okay? As far as files are concerned, you can usually only do it one byte at a time. And that's basically just an explanation of what is syncing and what is sourcing. And then this part talks about some files don't have a name and don't live in a folder. Okay? So what we call a pipe, is one of those files. Okay? It is just a connection between two places, between two programs. Okay, so we'll go ahead and process this part here a little bit slower. Since a file is nothing more than a stream of bytes, a conveyor belt where each item on the conveyor belt is a byte, it doesn't really need a name. Okay, it's just a conveyor belt. So if a file has no name, how is it specified and how is it accessed? Okay, that's a very good question. Okay, but it's also very fundamental to what we are going to talk about. So this is not theoretical. This is actually very useful of all the subsequent topics that we will have to talk about. So let's think about what can source or sync a continuous stream of bytes, but does not need to name the streams either. So, well, the answer is an input or output of a command line oriented program. Okay, let's do a demonstration here. There is a program called grep in Linux, and its only job is to search for a particular pattern and print out the content of that line in a quote-unquote file that contains that particular string or whatever that we are looking for. So let's go ahead and create a simple file. Okay, so this time this is a regular file, nothing special here. So we'll just call this test.txt, and we'll put some entries here: A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, A, B, C, and then 4, 5, 6. Okay, so this is a regular text file with only 3 lines, and these are the content of those 3 lines. Okay, nothing special. In Linux, there's a command called cat. It's kind of like type in DOS. All it does is quote unquote to show you the content of the file. So I can basically just, okay, let's show me the content of the file. It has A, B, C, D, E, F on one line, 1, 2, 3, 4, 5, 6 on another line, and then the last line has A, B, C, 4, 5, 6. Grep is really just saying, okay, give me a search pattern, and I can give you the lines that contain that particular pattern in a file. Is that okay? So let's go ahead and find 4, 5, 6. So grep works this way. You specify the pattern that you're looking for first, let's say 4, 5, 6, and then you give it the file that you are searching from, which in this case is test.txt, and when I press the enter key, what do you think would be the output of this command?
3, 4, 5, 6, ABC, 4, 5, 6.
Exactly. So we'll print the entire content of the 2 lines containing 456 as a subpattern. Yep.
Now, what if you're looking for a pattern, but you wanted to search multiple files that you don't know what file it's in?
Well, you can specify wildcard, as the file name, so you can search in multiple files. You can do recursively too, but that's not the point of this discussion. I'm slowly trying to move on to the concept of piping. Okay, so when I press the Enter key, not surprisingly, it found that 1, 2, 3, 4, 5, 6 contains 456, and then ABC 456 also contains 456 as the output of this grep command. Are we still doing okay so far? So right now we are still using files as a regular thing, like it has a name, it stores in a folder, it's on a hard drive, all the usual things that you associate with the concept of a file. So the next thing I'm going to do is to say, well, let's go ahead and do something a little bit different. Okay, let me just say grep 456 without telling it what file it's reading from or what it's processing from. Okay, what do you think is going to happen here? I'm not specifying any input file. Say again? Well, let's see what happens. This is what happens. The program is broken? No. Well, if you don't give it a file to process, it will default to the input, which is your keyboard. Okay. Now, keyboard is really just a name to refer to what we call, technically it's called a console, but it's really the keyboard. Okay, whatever you type is a file. So if you don't specify a file as an input file, it will default it to, oh, okay, I'll process whatever you type. So let's see if it works. Okay, let's go ahead and type something that does not have 456 here. A, B, C, D, E, F, G. Press the Enter key. Doesn't have 456, so it's not, there's nothing coming back from the program. Let's try 1, 2, 3, 4, 5, 6 here. Now observe closely. Okay, this is what I just typed. When I press the Enter key, it prints 1, 2, 3, 4, 5, 6 as the output of grep. So the first 1, 2, 3, 4, 5, 6 was what I typed. The second one is the output of grep itself, saying that, oh, what you just typed, which is 1, 2, 3, 4, 5, 6, has the pattern of 4, 5, 6, and that's part of the output. So now it is interactive. Okay, I type something, it processes it, and then it might print back what I just typed, depending on whether 4, 5, 6 is a part of that line or not. Yep.
You use grep in the program?
You can grep from a program. You can grep from anything.
I use it in a program, like I make a program, I use grep as a condition, and if it comes across that, then it spits out that.
No, because in C and C++ there's a string compare function to do that. So grep is only usable on a command line, but not inside the program. Okay. So I can keep typing something that has no 456 in it, and it doesn't do a single thing. It doesn't print back all the Z's. Or if I input a simple line with just 456, it echoes back because that is the output of the program. Okay. Are we still doing okay so far? Yep.
If you typed 546, it's still.
It would not print anything because the ordering is important. So 546 is not going to do anything because it is not in that particular order. Okay. How do we stop this?
Control-C.
Well, Control-C is one way. Control-C is forcing a program to quit. You're basically saying, hey, program, stop. Okay? But there's another way to stop. Okay? The other way to stop is to use Control-D. When you press Control-D on the keyboard in Linux, not in Windows, but in Linux, Control-D basically means end of file. EOF, end of file. So what I have just demonstrated now is a file that has no name. Because what was grep processing? It's processing a file, but what is the name of that file? It has no name. Okay, it's just whatever you type on the keyboard.
Did it store someplace?
Say again?
The
It's not stored anyway. It's not stored anywhere. Because whatever I type, it will store up to the end of that line, and then it will process it. But then it doesn't go anywhere. It's not stored anywhere. Okay. So that's the nature of a file. Doesn't necessarily need to have a name. It doesn't necessarily need to be stored anywhere. It is really just a conveyor of bytes. So in this case, the conveyor of bytes is, I'm the producer of the bytes. I'm the one who's putting the characters on the conveyor belt, and then grep is the one that is taking the bytes away from the conveyor belt to look for 456 in this case. Are there any questions about all of these concepts? Because the whole idea is to quote unquote debunk what we think we understand about files. Okay? What we understand about files is okay, but those are not all the files that we use in programming. Alright, so let's go back to the notes here because I want to relate what we talked about to what I have already typed here. So on a command line type of operating system or interface, all commands have two files already assigned to it, which is already open. One is called the input file, and the other one is called the output file. Those two files are always there when you're dealing with a command line oriented program. In fact, in the context of Linux, all programs, it doesn't matter whether it's GUI program or a command line program, every single program has an input file and an output file. Okay? Now, whether you give it something to process is a whole different story, but they do have the input file and the output file. When you type something on the keyboard as input to a program, that content, whatever you type, is now the sourcing stream. You are the one putting something on the conveyor belt, and your program is taking the input and it's basically taking all the bytes away from the conveyor belt for processing. When the program is done processing and generates some output to what we call, quote unquote, the screen, that is the output of the program. And the sink in this case is also called a console, which you normally say is the monitor or the window or whatever the text box is. But that becomes the output of your program. Are we doing okay so far? So when you interact with a program that is command line based, whatever you type is the input file to the program. Whatever the program prints or output is the output of the program. And both are basically files. They're basically conveyor belts that has bytes on it. So that stream is usually takes whatever a user types, that becomes the input. But in programming, in C and C++ programming, that particular file, which is the input file to a program, is also called stdin, standard in, or in C++ it is called cin. Okay, so we'll use these particular terms later on in some other programs. The stream that usually takes the output of a program and get it displayed on the text terminal is called standard output, which is also abbreviated to stdout, standard out, or in C++ it's also called cout. Okay, so those are the names that you refer to inside a C++ program to refer to the input and also the output of a program. And you don't have to do a single thing to quote unquote open or to arrange for those files to open. It is already done by the time your program has control. So there's nothing that you have to do to open those files. Okay, so this is a good time to kind of do a quick demonstration, okay, just to see what do you mean by that? Okay. So let's make a very simple program to use a standard in and standard out. I'll just create a folder for that. Okay, this is example 1. And then the first thing you have to do is to include IOStream as a header file. And then you have to also specify namespace, std, standard namespace. I'll explain all of these individually. We'll first get the program up and running first. So we'll go ahead and declare, let's say, 2 variables, x and y, and they're both integers. To read something into an integer is easy. In C++, you just say cin, which is the input file, and then you use greater than to say, whatever I'm reading in, interpret that as an integer in base 10, and then put it into variable x. Oh, by the way, read something else and put it into y as an integer. And then cout is what you use to output something, and the less than symbol is basically saying whatever is on the right hand side, print it out. So in this case, let's print x plus y, the sum of the two numbers, and that's all I need to do. That's all I want to do with this particular program. So this is a program that reads two numbers from standard in, which is whatever you type on the keyboard, and then prints the sum to the output of this particular program. Are we doing okay so far? So even though the syntax is kind of awkward, they're all the less than, greater than, but for the most part, the logic seems to be fairly simple, right? Read two numbers, print the sum, I'm done. Okay. I will go back to explain what is namespace later because it's kind of distracting from the main discussion here. Okay. So we'll go ahead and compile the program. -G to include a debugger in case we want to debug it. Specify the output file name to be example1. And warn all and all the other stuff. Then take example1 from CPP. And it doesn't like. I'm gonna cheat a little bit and read my own notes. Using namespace, okay, not just namespace. Go. All right, so now we are just going to run the program. Okay, what is the program doing right now? What am I supposed to do? Yep, because I didn't specify an input file, did I? So that means whatever I type standard in, it's the default input file. It has no name. This file has no name because it's just whatever I'm typing here. Okay, I type 45 as the first number. Press the enter key. It's still not doing anything. What am I supposed to do now? Give it another number, right? Okay, let's put 67 here. And as soon as I press the enter key, what should happen? It should print the sum of these two numbers, which is 112. 112. And it prints 112. And because I did not specify a line feed character, the prompt is right after the result of this program with no line feed next to it. But the program did what it's supposed to. Okay, so here's the fun part. What if I put these two numbers in the file and have the program to process from that file? Okay, so let's try that. So we'll go ahead and specify a really simple file. Was it 45 and 67? Okay, so I'm going to put these two numbers into a regular file. And how am I supposed to run the program, using input.txt as the input file? This won't work, okay? This is not going to work because example1 does not know what to do with whatever you're supplying on the command. Am I supposed to use this as the input file, or am I supposed to use this as the output file, or what? What am I supposed to do with this file name? Is that really a file name, or is it something that you just want me to process? It doesn't know. Okay, so this doesn't work. What works is what we call the redirect symbol, which is just a less than. The less than symbol on the command line basically means whatever is after the less than symbol, use that as the input file. So instead of waiting for me to type something on the keyboard, use this file as if I'm typing it. So now I'm redirecting a particular file to become the input to example1, and it prints out 112. It processes the content of input.txt as if I just typed it. Yep.
I forgot the difference between a single less than and the double less than.
Okay, a single less than is used in the context of a command line interface as a command to Linux. The double less than symbol is used within a C++ program as a part of a C++ program. Okay, so the context is different. One is on the command line, and the other one is inside the C++ program. Unfortunately, they have the same similar syntax, so that's why it can be a little confusing. Now, I can do something even more interesting with this one. I can also say, don't print the output to the screen, to the console, which is the default output. Instead, let me tell you where to print it. Okay, so I can specify a file name in this case, like output.txt. When I run this command, it doesn't seem to do a single thing, okay, because 112 is not a part of the output that I can see on the console. So where do you think I can find 112? Output.txt, right? So let's go ahead and do a cat of output.txt, and sure enough, 112 is there.
Did it just create output.txt?
Yes, it creates if the file does not exist yet. Okay. Now to make this even more confusing, I can use greater than to specify append to. In other words, if output.txt already exists, do not overwrite it. Just append whatever is the output of example 1 to the end of the existing content of that file, which can be useful if you're keeping a log file because you don't want to necessarily destroy what is already in the file. Okay. Now to bring this discussion all the way back to the black hole, if I don't want it to print out and I don't really want to store it anywhere, I can now redirect it to the black hole. Okay? Because the black hole is doing one thing. You give it a conveyor belt with stuff on the conveyor belt, it just grabs whatever's on the conveyor belt and tosses it right. That's all it's going to do. So when I run this command, it doesn't do a single thing, and it really doesn't do a single thing because the output is there, but nobody's storing the output, nobody's processing the output, it's just tossed away. Are we still doing okay so far? Just one more thing. I can take example 1 as a command, and instead of using redirection, I use the pipe symbol. In other words, I don't want to specify where to store the result of this program. Instead, whatever is the output of this program, use that as the input to the next program. Okay? So the next program in this case, I'll just use grep here, and I'll just grab 11, and that becomes the output of grep. In other words, in Linux, because of the use of the standard input file and the standard output file, you can now chain commands where the output of the first command becomes the input of the second one, the output of the second command becomes the input of the third one, and so on. And that really is useful because now you can daisy chain, different commands to as a combination, as a sequence. That sequence of commands will do more than what a single command can do. And that's one of the trademark of Linux user interface thing is you can daisy chain a lot of these things. And as you build up your knowledge of these commands, you can start to make things work together in interesting ways to get results really easily. But it takes years of training to to get to any point of making it useful. But imagine this. I mean, you guys are just starting out, right? I mean, so you have plenty of time to build up your vocabulary and skill set, to combine all of these commands. All right, so we are running out of time today. I'll see you guys on Wednesday. Okay, so read ahead of me a little bit just so that you know what I'll be talking about.
You only had to go to the Expo 1 day this